Hello everyone, we are from Group 3 for Pollution Control courses in Section 1 and want to present about raw water pollution issues in Sungai Gong. But before that, I want to explain water treatment process in Malaysia. So, this is the flow diagram of water treatment in Malaysia where the water intake comes from a river and reservoir, which at this part, the big object like leaf and plastic are removed. The second step is coagulation and flotation. This part where the chemicals are added to the water, and this chemical will make a small particles stick together and form a big clump called floc. Second part is a sedimentation where the water flows into a large tank and the floc settles down to the bottom. So the clear water on the top and the floc at the bottom will remove. Fourth part is filtration, where the clear water passes through sand and gravel. This removes fine particles and germs. And the next thing is disinfection, where the chlorine or other disinfectants are added. This kills harmful bacteria and virus. And last part is storage and distribution, where the treated water is stored in reservoir that is sent through pipes to our home. As we know, water pollution issues continuously occur due to illegal industrial discharge. So by 2020 until 2025, in 5 years back, that is constantly water pollution issues, where the river pollution in Selangor causes by water treatment plant to close. So many of our houseland no water supply. In 2021, Sungai Klang listed as polluted river with a high plastic waste. In 2022, there is 29 rivers in Malaysia were classified as polluted by DOE. In 2023, the numbers of dropped slightly, but the 25 rivers still were polluted. And 2024, 27 of the 672 rivers were polluted. Selangor recorded about 18 water pollution cases. Last year, in 2025, there is water pollution issue occur in Sungai Johor, where the activities of sand mining by industrial causes a muddy and highly turbidity of the water, make water supply to houseland cut. So, let's focusing on our issues about water pollution in Sungai Gong Klang, which this issue about water contamination of ammonia in river. Due to the contamination of the ammonia in the raw water river puts the health of the over 40,000 residents at stake as threatens to damage the ecosystem and the environment. So, based on inspection, there is more 300 of licensed factory and 30 illegal factories in surrounding area in the river. Due to illegal discharge, the river drowning in excessive ammonia, poisoning the water with dangerous nitrogen compound. BOD and COD are showing the river is choked with waste and chemicals that consume all its oxygen. And the TOC and TSS are overwhelmed, show the water is turned murky and lifeless. And the river is classified as Class B, which the worst category of the river quality, which declare as a dead, unfit for drinking, farming, or even for sustaining life.
Hello, my name is Yap Teming, and I'll be explaining the main causes of contamination in Sungai Teluk Gong. Sungai Teluk Gong in Klang is heavily polluted to the point that aquatic life can no longer survive. This pollution affects over 40,000 residents nearby and poses a serious environmental risk. From the map, we can see that the contamination stretches out about 20 kilometers from Teluk Gong to Port Klang, with 4 main sampling locations: Jalan Pusara Indah, Jalan Teluk Gong Bridge, Pangkalan Nelayan Sungai Undang, and Pangkalan Nelayan Jalan Prajurit. Independent lab tests show how high levels of organic and nitrogen pollutants, creating conditions toxic to aquatic lives. Next, we will see where these pollutants are coming from and what activities are contributing to the river's condition. The first one is industrial activities. It is a major contributor, with over 300 factories in the area, including 30 built illegally on agricultural land. Illegal dumping also occurs, such as washing oil carrying trucks at Jalan Ikan Bawal, which release grease and chemical solvent into the river. Domestic sewage, farm runoff, and uncontrolled waste from township add more organic pollutants, increasing the river's toxic load. Now we'll look at the specific chemicals that are causing this problem. Sungai Teluk Gong falls under Class 5 in the National Water Quality Standards, the worst pollution category. Excessive levels of ammonia, biochemical oxygen demand, chemical oxygen demand, and total organic carbon were recorded. This compound make the river even more polluted than typical industrial or domestic wastewater. Even areas that look clean can have hidden pollution. Total suspended solid were measured at class 3, showing that chemical contamination is not always visible. Finally, we discuss the challenges authorities face in controlling and reducing this pollution. A lack of effective enforcement has worsened the problem. Reports of pollution from several months ago did not lead to a decisive action, allowing water quality to decline. The government amnesty program allowed factories without permanent permits to continue operating under temporary licenses, while factories in approved zone may comply. Illegal operations in agricultural land violate regulations. Local authorities, including the Department of Environment and Klang City Council, are monitoring illegal factories, but ensuring full compliance remains challenging. That's all from me. Thank you.
Now we're moving on to the impact of the ammonia contamination towards the ecosystem, human health and treatment facilities. Firstly, we will dive into the impact of ammonia onto the environment and ecosystem through eutrophications. When ammonia enters the river or lakes, it adds excess nutrients, specifically nitrogen and phosphorus, which causes the algae to grow and form an algae blooms. When these algae eventually die, it will consume a large amount of dissolved oxygen in the water. As this oxygen decreases, aquatic animals such as fish cannot survive and breathe properly, which also creates a dead zone where life are no longer available to survive in the water. Secondly, soil acidifications. When soil bacteria converts ammonium from excess fertilizers into nitrates, they release hydrogen ions that increases the soil acidity. This acidity creates a natural lock where high level of soluble aluminum and iron turn essential nutrients into insoluble forms that plants can absorb. Most critically, at pH below 5.0, aluminium toxicity occurs where the dissolved aluminium physically damage and stun root system, leaving them too thick and brittle to reach the nutrients they need to survive. The next point is on human health risk, where the exposure to ammonia gas causes severe respiratory problems, including reduced lung function, irritation to eye and throat, and increased coughing and phlegm expulsions. Beyond the lungs, it can also lead to internal organ damage by causing burn and injuries to the digestive tract. These complications are extremely serious and can potentially result in organ failure and even death. Finally, is increase in treatment costs. Ammonia contamination makes water purification becomes more difficult and expensive. It requires significantly higher chemical dosage, such as chlorine for effective oxidations. The need for specialized filtration and neutralization causes a sharp increase in operational costs, while high contaminant loads accelerate equipment wear and energy consumption. Ultimately, high-level ammonia discharge led to total ecosystem collapse, as seen in the devastation of Sungai Gong.
Hello everyone, next we'll be doing solution. We have 4 different preventive measures. So first, real-time river water quality monitoring. Continuous sensors detect changes in parameters like pH, BOD, COD, and ammonia early on, so the authorities can respond quickly before it spreads. Second, strict control and inspection of industrial effluent discharge. So regular inspection ensures industries comply with the discharge standards. 3. Mandatory sewage treatment before release. It removes organic matter, nutrients, and pathogens, reducing oxygen depletion and health risk in river ecosystem. Finally, we have regulation of agricultural runoff. It limits the fertilizer use and install buffer strips to reduce nutrition runoff. As you can see from the picture, we have 3 different zones. We have zone 1 for preventing erosion, provides organic material, provides shade. And second zone, we have slows water flow. And finally, zone 3 pulls out the nutrients, so it stops chemicals from entering the rivers. And the second image is the sewage treatment plant in Kuala Lumpur. Next, we have our pollutant focused solution. First is biological treatment to reduce ammonia. So microorganisms convert ammonia into less harmful forms through nitrification and denitrification. It improves water quality and reduces toxicity. Second, advanced oxidation and filtration for organic compounds. So processes like ozone or UV oxidants break down the organic pollutants, while filtration removes the remaining particles from the water. Third, aeration system to lower BOD. Adding oxygen enhances microbial activity, allowing bacteria to decompose organic matter more efficiently and reduce oxygen demand in the river. Finally, we have chemical and biological treatment to reduce COD. So the chemical, oxygen, and biological processes work together to degrade both biodegradable and non-biodegradable organic pollutants. These are the example of a recent tank. Next, we have call to action. So as resident, we report river pollution to local authorities by promptly informing the DOE or local councils whenever you notice illegal dumping or any other suspicious activity in the rivers. Second, as industry manager, we report to the DOE and the emergency response team upon any detection of ammonia leakage. Delay is not an option. And finally, as government and authorities, we strengthen enforcement and inspection, impose strict penalties on illegal dumping, improve real-time water quality monitoring, and support restoration and long-term sustainability plans. And this is our reference. And I think that's it from our group. Thank you.